Advanced Math Lesson 19. Part A is about nonlinear systems. You've been solving systems of linear equations where they looked a lot like the second one. When you graph it, you would get a line. Now, one or both of them will be nonlinear. So if you graph it, it could be a circle or some kind of curve. And, well, like it says, a nonlinear equation is an equation whose graph is not a line. And a system of these, we could have two or three. We're only going to be doing two right now. And when this happens, you might get no answer, 1, 2, 4. There could be many answers to these, or none at all. Like linear systems, nonlinear systems are solved by substitution and elimination. So you do them basically the same way, you just don't know how many answers you're going to get. And I can demonstrate why it just was a little sketch. Like it says here, for example, that first equation is actually the equation of a circle. And so you have a circle and a line. Well, they might not intersect at all. You know, the circle might be here and the line's here, and then there's no answer. Or maybe the line is tangent to the circle, so it just touches it at one point. Or maybe the line goes right through it and there are two answers. One of the other examples down here, we have a circle and a hyperbola. You might get up to 4 answers for that one. So we're going to have 3 examples here. I really enjoy these. I hope you do too. Let's see. So, like it said, substitution or elimination, just like we normally would do. And I think I'm going to choose to do substitution for this one. If I wanted elimination, I would have to square both sides and the bottom, and then we get this extra term. And it's easier just to do substitution. For one like this, let's just get y by itself. Y would equal x plus 1. Okay, so then we're going to substitute that into the first equation, which means we have x squared plus, and instead of y, I'm writing x plus 1. And so that I don't forget to square it and actually FOIL, not just square the x and square the 1, I'm going to write it twice. And then that equals 9. Okay, so we have that x squared, and then we FOIL this. So x squared plus 1x plus another 1x, 1x from the outer, another 1x from the inner, plus 1, and that equals 9. All right, so then we have 2x squared plus 2x, bringing that 9 over, minus 8 equals 0. And I can divide everything by 2, so x squared plus x minus 4 equals 0. And I can try to see if this will factor. I would need factors of 4 that subtract to give me 1. It's either 1 and 4, which will give me 3, or it's 2 and 2, which gives me 0. So this is not factorable. So I guess I'll use the quadratic formula. You can also complete the square if you wish. If I'm doing quadratic formula, my a is 1, my b is 1, my c is negative 4. So x equals negative b, so the opposite of b, plus or minus the square root of b squared, that's 1, minus 4 times a times c, all over 2a. So x is negative 1 plus or minus, okay, so 16 plus 1 square root of 17 all over 2. Okay, so I have 2 answers for x. It's either negative 1 plus root 17 all over 2, or negative 1 minus root 17 all over 2. I need to find out the y that goes with each of those x's. So y is right here already by itself, and I'm Let's put an arrow. We're going to go over here now. So I'm going to substitute the x with the positive root 17 first in there and find out what y goes with that. So y equals -1 plus root 17 over 2 plus 1, but I'm going to make them have common denominators, so plus 2 over 2. So in that case, I get 2 minus 1 is 1 plus root 17 all over 2. So that's one of my points. I have -1 plus root 17 over 2 for my x, and my y is +1 plus root 17 over 2. But x might be -1 minus root 17 over 2. So that's the other one. And so that would be -1 minus root 17 over 2 plus 2 over 2. So my second point, my x is -1 minus root 17 all over 2, and then what I'm getting here is 2 minus 1 is 1 again, but then it's minus. So 1 minus root 17 all over 2. Those are the 2 points at which the graphs of these two things, the circle and the line, would intersect. The line would go through the circle. Don't give decimal answers. We want exact answers. Write them like this. Okay. In example 2 here, you have, that's a circle again, and then this one is like that. So they might not actually hit at all. They might not intersect anywhere. They might intersect up to 4 places. You know, the circle is like right in there. So 0 to 4 answers for this. Now for this one, if you take a look at the equations, you have a y squared in one, a negative y squared in the other one. The very easiest way to do this is using elimination. Okay, so just do whatever works the best. So it's set up already. I can just add my columns. The y squareds cancel. I have 3x squared equals, my minus 6 is 3. So x squared equals 1. So x is +1 or -1, could be either. So then I take +1 and put it back in place of an x, find the y, and then I take -1, put it back in place of the x, and find the y that goes with that. I'll go to this one. So putting just the 1 in first, I'd have 1 plus y squared equals 9. Y squared would equal 8. So y is the square root of 8, but that's root 4 root 2. So y is 2 root 2. Oh, but wait, I took the square root of both sides. It's positive or negative. So when x is +1, because that's what I put in, when x is 1, y could be 2 root 2. Or when x is 1, y can be -2 root 2. I didn't do when x is -1 yet. Looks like we're getting 4 answers for this one. Okay, so when we put a -1 in here, when you square anything, you're getting a positive. So it's going to turn out exactly like this. So when x is -1, we're getting the same y's. 2 root 2 or -2 root 2. All 4 points are points of intersection for the graphs of those two equations. Okay, 4 answers to that one. Next, we have a different looking equation. This also is two curves. It's just instead of being vertical, they're kind of diagonal. And this one's a line. I hope you recognize that's a linear equation. So you don't know. There might be no answer. There might be 2 answers. Let's find out. Let's see. What do we want to do for this one? Probably substitution again, because it's not like something's going to eliminate very easily. So that y is already by itself. We'll put that into the first equation. X times what y equals, negative x minus 2, equals negative 4. All right, so we distribute negative x squared minus 2x equals negative 4. I would like as many positives here as I can have in my equation, so I'm going to add these to both sides, and I would have that x squared plus 2x minus 4, because add that, I have x squared and a positive 2x with my negative 4, and that equals 0. Okay, if this factors, I would have factors of 4 that subtract to give me 2. 2 and 2 don't do that, and 4 and 1 don't do that. So this doesn't factor either. And again, if you prefer completing the square, you keep the constant on the other side and you can do that. I'm just going to use the quadratic formula again, I guess, although I could have done the other one just for an example of doing it. But a is 1, b is 2, c is negative 4. So x is opposite of b plus or minus the square root of b squared, so 4, minus 4 times a times c, all over 2a. Okay, so we have negative 2 plus or minus the square root of, here's 16 plus 4, which is 20, all over 2. And then that is the same as root 4 times root 5, so it's 2 root 5. And here you could factor a 2 out of the numerator and reduce. So we'd have 2 times negative 1 plus or minus root 5 all over 2. Okay, so those 2's cancel. X is negative 1 plus root 5 or negative 1 minus root 5? Negative 1 plus or minus root 5. Okay, so then we're just going to take them one at a time, put them back into the easiest equation to put them into to find out what y equals. Okay, so my first one I'm going to put where it's the plus, so I have y equals the opposite of x, so I'm just going to write that out, opposite of, and I'm using negative 1 plus root 5 minus 2, so that's the opposite of negative is positive, the opposite of that is minus. Okay, so that one I had for x negative 1 plus root 5, and I'm getting negative 1, my like terms there, minus root 5. Okay, so the second one's going to be where it was minus root 5 for my x, so the opposite of negative 1 minus root 5. minus 2. And so that is positive 1 plus root 5 minus 2. So for that x, which was, negative 1 minus root 5, I got negative 1 plus root 5. 2 answers. Fun stuff. But we're moving on to the next section now, which is factoring exponentials. Okay, so you know how to factor. Anytime you are asked to factor something, the very first thing you ever look for is the greatest common factor. Okay, and we're going to look at the coefficients first and then the variables here. So in example 4, we're looking for the greatest common factor for 8 and 12. So the biggest number that goes evenly into both of them. Right, it's 4. So we'll write a 4. And they both have some x's, so they're going to have some of those in common. And you hopefully remember when you're doing greatest common factor, you want the lowest exponent. Okay, these happen to be abstract exponents. They've got variables in them themselves. So we're going to compare the ends. We want the lowest exponent, 2n is less than 5n. Okay, so 2n, and I mean, it really depends on if n's negative, but the coefficients of the n's, 2 is less than 5. And then we have a positive 5 and a positive 7. We want the lowest one, so plus 5. Okay, that'll be our GCF. So then we start our parentheses. What do you take times 4 to get 8? X to the 2n plus 5 matches, so we don't need any more x's. Put our minus, and then what do you take times 4 to get 12? And we will need some x's here. We only have 2n out here for our GCF, but we need 5n, so 3 more n's. And we have a plus 5, but we need a plus 7, so we need 2 more of those. Okay, please remember, however many, like, there were 2 terms in the original problem here, there will be 2 terms inside the parentheses. And then to check and see if you did it right, you just distribute. Okay, 4 times 2 is 8, so it's 8, that matches the first term, minus 12. And when you're multiplying these x's, you add the exponents, right? So x to the 5n plus 7. It's right. I can move on. Okay, this next one's going to be fun. So let's factor the numerator here. And actually at this point, we should probably look at the thing beside it. When you're factoring a difference of 2 squares, dots is just the abbreviation for that, difference of 2 squares. This is basically a formula, but when you do reverse FOIL, like when you're factoring trinomials, your middle term is just a 0 here. So you would want factors of b that subtract to 0, so they'd have to be the same. So it's, I shouldn't say factors of b, it was factors of b squared. So it's the square root of the first term, the square root of the second term, and their opposite signs. That's how you're getting a negative for the second one here. And when you do the outer and inner, those cancel. That's why there's not a middle term. Okay, so for instance, just with numbers, if we had x squared minus 9, and you were asked to factor that, okay, that's the same as x squared plus 0x minus 9. So doing it the way you're used to, you're going like that. You need factors of 9 that subtract to 0, which means they have to be the exact same number. So you put the same number in, and they have to be opposite signs to get you the negative. Okay, so the shortcut is just, oh, both of those are perfect squares. I need an x in the beginning of both of them. I need the square root of that, so 3 in the end of both of them. Put opposite signs in. Okay, so that's what this is about. And I mention that because I noticed some differences of two squares right here, which is why that box is so conveniently located to this example. Okay, so to factor the numerator, and this would be, because there's no GCF, we always look for GCF first, but there isn't one. So this is the square root of that will be x to the 2d. And the square root of the second one here is y to the 2d. And so one will have a plus and one will have a minus. And we can FOIL and prove it to ourselves. This is x to the 4d, because we're adding exponents when we multiply, minus x to the 2d, y to the 2d, plus x to the 2d, y to the 2d, so they cancel, minus, because these are opposite signs, y to the 4d. Because again, they're both y's, so we add the exponents. So that's the same as this. And x to the 2d, y to the, that's nice. X to the 2d minus y to the 2d. That binomial totally matches that binomial. And this is a factor of the numerator, so that and that cancel, and your answer is just x to the 2d plus y to the 2d, and that's it. Wasn't that fun? Okay, more factoring in part C. Now we're not factoring the difference of two squares. Now it could be a difference or a sum of two cubes. And so I tend to refer to these as SOAP problems because of just a little acronym over here. When you have a sum or difference of two cubes, here's what you do. It's going to be the cube root of each of them in your first little set of parentheses, no matter what. See? A cubed, B cubed, AB, AB. The sign in that will be the same as what it was in the original. If this is a minus, that's a minus. If it's a plus, it's a plus. And then you always have a squared, AB, and B squared here. The signs are the only things that will change. Okay, so in the first one it was the same. The next sign will be the opposite of whatever the original problem had. And then the other one is always a plus. It's always positive. SOAP, same, opposite, always positive. So we're going to try them out. In example 6, we have this one. This is a sum. Okay. And the first, you might first want to write down what is A and what is B, because this is A cubed, this is B cubed in our little formula. Okay. So my first term, I'm going to go ahead and put it here because they go directly into the parentheses. The cube root of 8 is 2. And then when you're doing cube roots of variables, you just divide the exponents by 3. So x, you don't have to write the 1. When you divide 6 by 3, you get 2, so y squared. Okay, and the cube root of that's just z. And so remember, the thing is SOAP, same. The first one's the same, so it's a plus. Okay, then we need another set of parentheses, and it will be this squared. So 4x squared y to the 4th. Same opposite. And then it's AB in the middle, so that times that. 2x y squared z. Same, opposite, always plus. Okay, and then we square this, z squared. And I'm not going to take the time in the video here, but if you multiply both of these times each of those, you can prove to yourself that it works. Okay, so as long as you remember the process and get your signs right, it will work. And if you want to take a minute and actually multiply them, you can check it out. Okay, now we have a difference of 2 cubes to practice with, and then that'll be it for the notes. So, cube root of 27, 3. Remember, for the variables, when you're doing cube root, you just divide the exponent by 3, so m to the 3. Same sign, minus. Then the cube root of that, 2, divide 6 by 3. Okay, so there we go. And then this squared, that's 3 times 3 is 9. But then we're squaring this, we double the exponent. So 6, same opposite, so plus. And then it's that times that, 3 times 2 is 6. M to the third, p squared. Same opposite, always positive. And then we square this, 4p to the fourth. 2 squared is 4, but then also doubling the 2 gives us 4. And there it is. Again, you can multiply each of these by all of them and prove to yourself that it works. But that's how they're done. I think most of you are going to enjoy them. I hope you do. Have fun with them.